Welcome all of you to the computer-aided manufacturing, the manufacturing workspace training in Fusion 360. So first of all, I will open the CAD file. So this is my CAD file. Go to home page, then go to CAM samples, and here you can see the tutorials. Double click on the tutorials, then you can see the tutorial 1. So here this is tutorial 1. Double click on this tutorial 1. You will get this CAD file. Okay. Then I will change the workspace into manufacturer workspace. So these are the different workspaces in Fusion 360: design, generative design, rendering, animation, simulation, manufacturer, drawing, etc. So I will change the workspace into manufacturing workspace. Now this is the manufacturer workspace. So here this is the browser tab, and here if you want to change the unit, you can change the unit. Unit type is millimeter or inch. Okay, now it is millimeter default value. If you want to change the unit, you can click here and you can change the units. Then I will deal with the CNC milling machine, and first operation is the phasing operation. So I will go with milling. So here these are the different options: milling, turning, additive, inspection, fabrication, and utilities. So I will go with milling, then I will select the 2D face. So here you can see a new window is displayed. This is the phasing strategy window. Here you can see phase 1. On the top of this you can see there are 1, 2, 3, 4, 5 options. First one is related to the tool, second one is related to the geometry, and the third is related to the different heights: the clearance height, retract height, feed height, top height, bottom height, etc. And this next one is related to the pass, the passes. Then the last one, that is related to the linking. So I will select the tool. First I will select the tool using this option. Okay, if you want to select the tool, you can select the tool from here, and if you want to change the feed and speed, you can change the feed and speed here. So I will select the tool, and here I will select the phase mill. I will go to the tutorial metric option, and here you can see the phase mill. This is the phase mill, and here this is the diameter. The diameter of the phase mill is 50 mm. The diameter of this is 50 mm, and the flute length is 6. Okay, this is the phase mill. If you want to edit this phase mill, okay, you can click this view tool, and when you click the view tool, you can see the tool related options. Okay, you can see the cutter, the shaft holder, cutting data, post processor, etc. I will cancel this. I will select this, and I will select this tool. Now you can see the display of the tool. You can see the display. You can see the tool is displayed above the top surface of the workpiece. If you want to adjust this feed and speed, you can adjust this, or I will go with this geometry. Okay, once again go to 2D face, select the tool, phase mill, select, then geometry. So here this is the geometry. Here you can see this is the outer boundary of the workpiece. So this is the geometry. Then heights, if you want to adjust the different heights, so there are different heights: clearance height, retract height, feed, top, bottom, etc. Okay, so clearance height is the first height the tool rapids to on its way to the start of the tool path. Then the next height is the retract height, the second height, that is the retract height, the height that the tool moves up to before the next cutting pass, and the third height, that is the feed height, sets the height that's the tool rapids to before changing to the feed or planch rail to the end of the part. And then next is the top height, that describes the top of the cut, and the bottom height, this bottom height determines the final machining height or depth of the operation. So these are, if you want to adjust, say this height, clearance height, say I will change this height to 50, you can see this height is 50. From retract height, this clearance height is 50 mm. Okay. Or if you want to change the retract height to say 20, okay, you can see the retract height is 20, like that. You can adjust the various different heights. Okay. Then I will go to the passes tab, and here I will adjust this pass extension. Okay, so this pass extension actually represents the distance to extend the passes beyond the machining boundary. So here in the screen you can see a square. Okay, that square represents the machining boundary. Okay, so the pass extension, actually the distance to extend the passes beyond the machining boundary. Okay, you can see the pass extension as represented as two arrows, one in the two arrows, two lines with two arrowheads, one on the left side and one on the right side. So that represents the pass extension. So pass extension means the passes beyond the machining boundary. So I will enter this pass extension. Now this is 0 mm. I will change it into say 10 mm. I will change this pass extension to 10 mm. Then I will not change all other values. Then I will click OK. Okay, now you can see the tool path is displayed in the screen, and this is the starting. This red represent, this is the starting position, and this is the end position. This green represents the end position. Okay, so I will right click this and then go to the actions, and then I will click the simulate button. Then I will click the play button. When I will click the play button, you can see the phasing operation is completed. Okay, so this is actually when you click the simulate button, you can see a new window actually open, that is the simulate window. This simulate window is actually in the simulate window you can see three options: display, info, and statistics. So this display is actually related to the one is tool, toolpath, and stock. If you want to make this tool as transparent, you can click this. You can see the tool is in transparent. I will uncheck this. Then toolpath. Okay, then the second thing is related to the toolpath. If you want to see the toolpath as tail, you can click here, and when you click this, you can see the toolpath as like a tail. Okay, so if you click toolpath before position, okay, so you can see, or toolpath after position, you can see toolpath after position, or toolpath for operation, you can. Okay, so like this. Then if you want to display activate the stock display, you can use this option. Okay, so if you want to change this stock as a transparent, you can click this. If you want to activate this stop on collision, means if you tick this, when collision is happened, then automatically the tool will stop. That is stop on collision. Then info is actually related to the position, the X, Y, Z, the operation, the verification. Collisions, you can see collisions none. What about the volume? What about the start volume, etc.? Here you can verify it. Click the continue option, and so here you can see collisions none. Then statistics actually related to the machining time, the machining distance, the operations, tool changes, etc. So that will be in the statistics. So display, info, and statistics. Click close button. So now only one strategy, that is the phasing strategy. So if you want to see the code, you can click the post process button and you can select the milling option, and you can take the controller as Fanuc because I am using Fanuc controller. So when you use the, if your controller is a Heidenhain, you can select this, or it's a say it's a Siemens controller. Okay, so here, yeah, Siemens Sinomeric 840D. Okay, if your controller is Siemens Sinomeric, this one, you can click here. I am currently selecting this Fanuc option because I am using this Fanuc, and I will click the post button and then I will click save. Okay, so I will share the screen. So I will share the screen. Yeah, here you can see this is the the CNC code for the phasing operation. Okay, so here this is the starting. Okay, and this is the phasing code, and this is the final, the end. Okay, here you can see the starting and ending. You can see a percentage symbol. So this is the syntax of the Fanuc controller. Okay, so if you are using a Fanuc controller, the first line and the last line will be a percentage symbol, and all other G codes and M codes. So G90, G94, all other codes are there. So tool number 1, M06, this is tool number 1. What about the spindle speed? 955, M03, spindle rotation clockwise, etc. So all the G codes and M codes. So this is actually the CNC code for the phasing operation. Okay, so I will share the Fusion again. Okay, then I will close this. Yeah, then if you want to see the setup sheet, I will click this and then I will select this and I will share the screen, setup sheet screen. Yeah, here you can see this is the setup sheet. You can see the details about the stock, the total number of operations, the details about the tool and the operation. So here only one tool, because only one tool, that is face mill of diameter 50 mm, and here only one operation, that is the phasing strategy, phasing operation. Okay, so I will select this again, Fusion 360. Yeah, so phasing is completed. Then the next step is adaptive clearing strategy. So the next is I want to remove the material from the outer boundary of this workpiece. So I will go with this 2D adaptive clearing strategy, and I will change the tool. I will select the tool as flat end mill. I will go with this tutorial metric. So from this I will select, so here you can, yeah, flat end mill. So here you can see flat end mill. So I will click this. Okay, so again I will go with this library. Okay, so if you want to create a new tool, you can click this play button. When you click this play button, you can see you can select a tool. So these are the milling tools, these are the hole making tools, and these are the turning tools, and these are the cutting tools, and this is for probing, and this is the holder. So if you want to select a flat end mill, so here you can see this is the flat end mill. Okay, so I will select this flat end mill, and if you want to enter the description, vendor, product ID, product link, you can enter that values here. Here I am changing the cutter values. So here you can see this is a flat end mill and the unit will be in millimeters, and the clockwise spindle rotation and number of flutes as 3 and the material as HSS. And here the diameter is 10 mm. Okay, I will change the diameter into 8. Okay, and I will change the flute length into 22. I will change the flute length into 22, and the all other values same. Then I will select the cutting data. Here you can adjust the speed, the feed rate, the passes and linking, etc. So I will change the spindle speed as, say, the spindle speed is 5000 rpm, so I will reduce this into 3000 rpm. And the cutting feed rate, here the cutting feed rate is 1000 millimeter per minute, so I will reduce that cutting feed rate into 800 millimeter per minute. Then I will click the accept option. In this way you can select you can create your own tool. You can select a new tool. I will select this, click this. So here you can see the tool number 7, and it is 8 mm diameter flat. Okay, so then the next option, here you can see the spindle speed is changed, that is 3000 rpm, and the cutting feed rate is 800 millimeter per minute. Then I will select the geometry. Here this is the geometry, this is the outer boundary. Okay, then go to the heights tab. Go to the heights tab. If you want to adjust the height, that is clearance height or retract height, etc. Okay, so say I will change this into, say, 100 mm. Okay, you can change the heights. Okay, and all other values, I will not change any other values. Okay, then I will click OK. So here the toolpath is generated. So adaptive clearing strategy is used to remove a large amount of material. Okay, so here you can see I want to remove large amount of material from this place, this place, this place. Okay, so for that I am using this adaptive clearing strategy. I will click the simulate button. So here, here, okay, so that is completed. So then if you want to post process it, okay, select milling, then select the FANU controller and click the post button and click save. Yes. So I will click new share, and this, yeah, here you can see this is the CNC code. So the first is the facing. So this is the facing. So after facing, the next operation is the adaptive clearing strategy. So this is the G codes and M codes are related to the adaptive clearing strategy. Okay, and finally this is the end. So two strategies, that is facing strategy and adaptive clearing strategy. Then I will go with this Fusion 360, and then I will save this. I will close this. Then I will generate the setup sheet. Click the setup sheet. Yeah, this is the setup sheet, and I will share the setup sheet. Yeah, this is the setup sheet for program 1001. So the first block, that is related to the stock. Then next is the total details, that is the number of operations, 2, number of tool, here you can see number of tools 2, that is T1 and T7. Okay, one is face mill, 50 face mill, and the second tool is 8 flat end mill. Okay, so this here you can see related to the tools, these two are the related to the operations. So tools, the first tool is the 50 face mill, and this is the 8 flat end mill. So here you can see this is the 50 face mill, and this is the 8 flat mill. So the two operations are the phasing strategy and the adaptive clearing strategy. So I will share again. Okay, and that is adaptive clearing strategy. Then I will go with this finishing, that is 2D contour. This is for finishing operation. I will select this 2D contour. I will select this 2D contour, and the tool is actually same 8 diameter tool. Then I will select the geometry. Okay, so here you can see an arrow. This is for this direction or opposite direction. If you click this, you can see the direction will be opposite direction. Okay, and all other details same. I will not change anything. I will click OK. So go to actions and simulate, and I will click this. Sorry. Okay, so I will select this edit tool. So go to actions and simulate. Yeah, that is the finishing. So if you want to see the G codes and M codes, go with this milling, Fanuc controller, and post. Save. Yes. And here I will share this. I will share the code. So here this is the starting code, and here this is the 2D contour strategy. This is the code, G codes and M codes for the contour strategy. Okay, I will close this and I will click this. Yeah, so I will click this and generate again. I will generate all the toolpath, phasing strategy, adaptive clearing strategy, and contour strategy. So I will generate all the operations, then I will post process it. Select the milling option, controller as Fanuc controller, and click the post button. I will save this. So when you click the post process, you will get the code, G codes and M codes. Then finally, you have to generate the setup sheet. Okay, so I will go with this actions and click the setup sheet. Okay, so this is the setup sheet. So that was about the so yeah, so that was about the phasing strategy. Once again, we have completed. 1 minute, the fusion is not. Yeah. So So today I have explained the three strategies, that is phasing strategy, the adaptive clearing strategy, and the contour strategy. So the phasing strategy is for the removal of material from the top of the workpiece. So this is the phasing strategy, and generated the codes and setup sheet. And then after that, for large amount of material, I am using the adaptive clearing strategy, the removal of the material from the outer boundary of the workpiece, that is the adaptive clearing strategy. And this is the adaptive clearing strategy, and generated the codes and also generated the setup sheet. And finally finish this outer boundary, okay, contour strategy, final finish, and generated the codes and generated the setup sheet. I hope it's clear. I will upload this video in that Facebook group. If you miss the class, you can watch the video and practice it. So thank you all.